pretty frequently this year at a number of different locations, conferences and Java users groups. I am from a tech stack. I'm using, I should mention that probably before we get ahead. I have Podman desktop running, which is running Podman, handles all the containers on my laptop. And the application is built in Quarkus. So I'm in an application. I've generated a Quarkus app here. Let's go ahead and get that started. So just in case, for background, what you see in here, Quarkus is going to figure out that Podman is running, and it's going to spin up containers for all the stuff I need. So if you kind of notice here, like it's already spun up a database. So that's why I don't have to do anything special for that. But that's what's going on in the background. So what I've got here, we're going to talk about domain-driven design, which if you have not used before, it is a little more complicated than, say, traditional application architectures. There's a lot of benefits to it, though. Hopefully we'll see that why. And I should probably start also with a couple of other resources. I mentioned this is going to be all code. There's no slides. I do have a couple of web pages, though. So this is the initial book, Domain-Driven Design, Tackling Complexity in the Heart of Software by Eric Evans. It's a fantastic book. If you really want to get into DDD, you really have to read this book. I would kind of recommend starting, though, with Domain-Driven Design Distilled by Vaughn Vernon. This is a lot smaller. It's about 100 or so pages. You can whip through it really quickly, and it gives you sort of a good overview. Which, by the way, this presentation, I have a much longer version of this. I typically do a longer version. We only got about half an hour today, so it's going to be really, really fast. I'm going to talk really quickly. So this is a great book to start with, Domain-Driven Design, then this is the real one. And a lot of people who really become DDD practitioners will read this book again every couple of years or so. So let's, I thought I would start by first, let's look at what is a pretty basic or typical application. Let's go into presentation mode. So I've got a REST app called Greetings, right? And what do we do here? Let's just go, I've got Postman running here. We can post a greeting. So you see, we say, we're just going to post some JSON, right? We're going to say, hello, DevConf, and the authors, or hello from DevConf, right? We'll just post that. Let's send that. And if we looked over here, we should log that, right? We did. We put that into the database. We inserted that greeting in the database, and let's go. We have a get here that'll pull all the greetings out, right? So got one in there. Let's add another one. Let's say, good afternoon. And we're in Brookline, right? So we'll say, from Brookline, we'll say, good afternoon. So super simple CRUD application, right? And this is exactly like what you expect from a normal CRUD application, right? We're post transactional because we're talking to a database, log, that we're debugging that. We're using a repository pattern, and our repository pattern is persisting the object. If we look at these objects, right, we can go in here. It's a greeting. The only thing that might be a little tricky, if you haven't seen Hibernate Panache before, it's part of the Hibernate ORM framework that came out with Quarkus. We just extend that entity, and it gives us a bunch of functionality. So it gives us the active record pattern, and it lets us make a repository really easily. So all I have to do here, and if you've used like Spring JPA or this pattern, this is a pretty common pattern, I just implement Panache repository, and it has a bunch of methods I can just use. That allows us to encapsulate our persistence logic. So this class looks kind of normal. Most developers would be very familiar with this kind of application. So let's do this, or let's rebuild this as a domain-driven design application. And to start with domain-driven design, we can just get rid of all this stuff. Talk about some of the ideas here for DDD. Actually, we're short, so I won't retype everything. But in a domain-driven design, what you want to do is you want to work inside of a particular domain. And I think part of the reason that this is a big deal is because of the rise of microservices and being able to build distributed architectures, which Kubernetes naturally enables, means that you have to figure out how to distribute the application. So let's say if we're going to say our domain, like we're at a conference. So let's say our domain would be a conference. Subdomains within that conference would be things like speakers, a call for papers, social media, agenda, scheduling, attendees, things like that, right? Those would all be subdomains that are part of our conference. And if we're building, say, microservices to run on Kube, Often those would be separate microservices. So we would have an agenda microservice. We'd have a call for papers microservice, right? And those would all, the bits of those functionality would be deployed separately inside of their own applications. So one of the two key objects inside of here is domain objects and events. And domain objects are the things that encapsulate all of our functionality, all the things that really, all the business logic inside of an application. And this is different than you'll find. So often if you've done a lot of front-end work, you're used to like encapsulating a lot of things on handlers or on event handlers, like especially inside of JavaScript or in front if you do fat client kind of code. Often this stuff goes in a controller in a web application or inside of a post method. But inside of DDD, they get encapsulated inside of a domain object. So for instance, we might have an attendee domain object in a conference, and all the logic around registering that attendee would be inside of that domain object. Events are things that the business cares about, and they are also immutable statements of fact. So if somebody registers for a conference, you can have a registration event, attendee registered event. So that happens no matter what. The person could cancel or ask for a refund or no-show, but at one point in time, they did in fact register, right? We did charge them. We need to do stuff like that. So we want to keep track those, and then often in distributed systems and in DDD, parts of the system communicate over those events. So we can communicate an attendee registered event, and then other parts of the system can react to that. So let's, before we talk about more concepts, let's go take a look at some code here. So let's come over here, and we have our basic greetings. So I thought we'd have a thoughts. We'll have greetings and thoughts. And let's start off, we'll re-implement the same kind of CRUD application. So let's have a thought resource. And let's not worry about that. And we will create a resource. And you'll immediately see that this is going to be more verbose. So let's we have a post method, right? And we'll say public. So the way we did the greeting, right, we returned a greeting. So it would look something like this. We would say thought, add thought, right? Thought, and we'd say thought created thought. First thing we're going to notice is we're not going to send objects back and forth over the wire. We'll send a DTO, right? So we're going to use a small, lightweight object. Let's do, we'll create a Java record, right? Because this is going to be immutable. And we'll say string text and string author, right? So we have an immutable record. It's going to be our DTO. And we'll return that back. Actually, you know what? We'll put one more. We'll do that for now. And the argument coming in, we're also not going to pass objects over the wire. So we're going to have a create thought command. And the create thought command is essentially going to be a very similar thing as well, right? So immutable record. And we're just going to make this super easy, string text and string author. So the first thing to notice here is, we'll say return new thought DTO. We'll do that at the moment. So the first thing is we're getting a command to come in, and commands are similar. They're related to events, but commands cause an action to happen, right? So they're not important in and of themselves, but they cause something that the system cares about to happen. So in this case, they're going to cause a thought to be created, right? So what we're going to do, if we look back on our kind of traditional CRUD application, I would create a thought and persist it itself, right? But we're not going to do that. So what I'm going to do is, instead of doing anything in this class at all, I'm going to inject. So I'm going to use dependency injection, and I'm going to have a thought service there. We'll create our thought service. And I'm going to give it an application scope. This just means Quarks is going to instantiate one of these things and make it available for us. And what I'm going to do, I'm going to say thought service, add thought, and create thought command. And what I'll get back here, I'll get our thought DTO back from that, and then we'll return that out. Let's get rid of all this. Sometimes all autocomplete's not so useful, right? Doesn't always help. So what we're doing, this is significantly different, right? So all I'm doing is I'm bringing in, this is going to be marshaled from JSON. Quarkus is going to handle that, right? So JSON's going to come in. I'm going to post some JSON. I'm going to marshal that into a command, and then I'm going to pass that command over to this service. And this service is called an application service, right, or a domain service, right? So this is going to work inside of the application, and it's going to help orchestrate the actions that happen. There's two different kind of services. This is going to orchestrate what happens. Another service would be like a translation service, just kind of some functionality that gets added in but isn't really core to the business. So let's implement this method here. We will create method add thought. And I mentioned that this needs to orchestrate what is happening. So the first thing we're going to do is we need to create a thought. We're going to need to persist that thought. We're going to need to create an event, right? Because we're going to want to let the rest of the system know that this happened. So we're going to publish the event, right? So we have, and then return a. Well, we can do with the thought detail later. So what we're going to do, we're going to create a thought. We're going to create an event. And we're going to let the rest of the system, we're going to create something that can be persisted as well. So let's come in here. Now, there's two reasons that we're doing this. One reason is the hexagonal part of the presentation is the rest resource that we have there is considered an adapter, right? So it adapts the internal core logic of the system to an external part of the system. In this case, it's a REST endpoint. We're also going to implement a Kafka endpoint here and a database, right? So you have entry input adapters and output adapters, right? So our REST is going to be an input adapter. We're going to use a database and Kafka for output adapters. The other thing that's really, really nice about using DDD is that we're going to be able to encapsulate all of the logic around these thoughts inside of a thought domain model. So we're going to say thought, create thought, and we'll just give it the create thought command. We'll give it the raw things here. So text. So now we'll get into our domain object. Let's create a domain object here. Create class thought. And this thought is going to represent thoughts in our system, right? And so we will say public static what's important about this now is all of our business logic goes in here. So let's say when we have some unique business logic. So let's say if, that's really nice, that's validation logic, but I want to say business logic because we can check for validation. If text equals Ubuntu is the best OS ever, throw an illegal argument exception, right? So we've got some logic here saying that's not the case. Right? We can do other things like let's say else if text equals I wasn't going to say Windows 11. I was going to say wow, this is a little our code complete's a little snarky, right? Throw illegal no. Right, so this is where we're going to put all of our complex business logic, right? And this is one thing that's really nice is, so even if you inherit my code, right, exactly, and somebody says, I've got this other new weird exception, we're also going to be, we're going to add in something about something else, right? You know exactly where to go and implement that code, right? So all the complexity of creating this object goes in here. So I've got business rules around the object, but I also need to do multiple things, right? So I need to create a thought. I also need to create an event, right? So I can say thought created event equals new thought created event. And I mentioned that this is going to be, and we'll just add let's just add in a timestamp or something here, right? So a thought created event. So I've created my thought and I've created my thought created event, and I need to return two objects, which Java doesn't really want you to do. So what we will do is we will do thought created result. This is just a pattern that that I got. I get this pattern. Chris Richardson, microservices.io, the guy that created Cloud Foundry, right? So this is a pattern of his, public record, and we're just going to use this. This is just going to encapsulate our thought DTO, our thought, we'll create our thought, and thought created event, right? And this just allows us to return the result, right? So we've encapsulated the logic. So the thought itself, the domain object knows what has to occur to create a thought. It also knows how to create the event, right? So then we can push this back and we can say thought created result equals. And now we can deal with that. So we've created our thought and we've created our event. We need to persist the thought, right? So let's give ourselves. So now here's another little tricky thing here, right? So you notice my domain object is not an entity, but I want to stick something in a database, right? So I want to create an entity. I want to say a thought entity, and we will say, actually, let's get our things out of here. So let's say thought. And thought create event result. Create event. We'll create a class here. And we'll extend panache entity. String text. Constructor. Empty constructor for that. Thought entity. Oh, whoops. Constructor with both. And then let's get a repository. We'll also use the repository pattern here as well. And the same thing, we're going to implement panache repository. So we can say thought entity repository persist. So now we have a second adapter. We have an output adapter, right? So in this case, talking to our database, this is an output adapter. We have an input adapter, which is our REST, output adapter, which is our repository. We're going to add a second output adapter, and we want to publish this event, right? So we're going to publish this so other parts of the system will know that that a new thought has entered the system, right? So let's also inject. Why don't we call an event publisher, and we'll create a class. Oh, you know what? We need to add some classes here. Quarkus extension add messaging Kafka. All right, so event publisher, and then I need to let IntelliJ know that I have monkeyed with the class path. We'll synchronize the project. All right, so now we'll be able to use our code complete. So what we're going to say is we're going to have a channel thoughts out, right? And so what we will say is emitter, and we'll say a thought and then we'll say public void publish, right? So an emitter is just an artifact that's going to send this message out to Kafka. So now we have a second outbound adapter, right? First outbound adapter is to the database. Second outbound adapter is to Kafka. And now what we will do, we're persisting our database. Now what we'll do is event publisher publish event. Let's just put some log files to f event sent, right? Let's yeah. So there we go. Get some logging. Take a look at that. One other thing I'll need to do here, because we're talking about a database, and this is the event publisher is going to run on a separate thread, so it's asynchronous. So I'm just going to need to do a little bit of transactional stuff here. Quarkus transaction. No. Acquire new. Run. So all that's going to do is it's going to run that in a transaction, right? So database transaction, we can commit that. And then we're going to publish our event, and then what our service is going to do is we're going to encapsulate the actual domain objects so that the rest of the application doesn't see that, and so we will translate this to a new thought DTO, right? Let's go ahead and put our database ID in here, long ID. So now what we've done, let's come over here and see if our thoughts, we have a thought here, post, thoughts. Oh, might need to recompile. I think I started up while I was still coding, so we have a little bit of a problem there. All right, looks good. All right, now let's take a look here. All right, so what we did is I sent in a message. It's always a great day to code. Let's see. All right, so if we look here, we can see in our logs, right, we're writing the database. We should also look, Quarkus has a dev mode. So let's visit our dev UI, and this shows us what's going on. We can look at our Kafka topics here. So thoughts out. And there are rules, right? So, and by the way, that's in the background, like Podman has spun up, Kafka in the background, right? So we are now passing messages into Kafka. So if we go from the beginning to the end, right, and walk our way through this application, we have got we have an adapter, right, which is a REST adapter, and so we send a command into our adapter. This grabs our command and then sends it over to a service. So in domain-driven design, adapters are inputs and outputs to the system. Services orchestrate what happens inside the system. I mentioned there was two kinds of services. So application service is going to orchestrate what happens inside the system, which is what this is doing, right? It handles the creation of a thought, persistence, notifying the rest of the application about the events. Another kind of service that we would have, let's just say we have like a translation service, and this would be like a domain service, and this is kind of just functionality that doesn't really belong anywhere else. So we could have, let's say, public static string translate thought. Yeah, we're not going to actually implement this, so we'll just say like we will just return conf. Right, so functionality like this, common things you would see like currency, often translation, things like that, kind of belong in these kind of services. But the application service we have here, this is going to orchestrate what goes on in the application. So what we're going to do is we are going to delegate all of the business logic, like all of the complex logic of creating a thought, into the domain object, the thought itself. So that's what we have here. We have our complicated business logic. We then are going to handle what it takes to create a new thought object. We're going to create a thought created event, and then we just return that back to our service, which is handling the orchestration. So it is creating an entity. We want to separate the entity from the domain object because the entity represents a record in the database. You don't really want to mix those together. One, it makes for really ugly code. Also, it's just a nice, clean separation of concerns so that my domain object really only deals with business logic. It doesn't have to deal with persistence or anything else. I'm going to store that in the database, which is an output adapter. And then I'm going to publish the event, which is another output adapter, right? So input adapter from REST, I go in, everything is orchestrated by the service. The logic is encapsulated inside of the domain object. And then an entity is persisted into the by a repository pattern, and then adapters send a message to the rest of the system. So that was a very quick introduction to domain-driven design. I think that's very close to the end. Any questions or?
Yeah, if anybody has any questions, there's only 3 of us, but just raise your hand and I can pass the mic.
If you're interested too, on my GitHub repo, there's a workshop too that I did at Domain Driven Design Europe earlier this year. You can come in and you can run this you can build this code out yourself. It goes into a lot of, I mentioned like this is a short version of this talk. Usually go for a lot more time. We talk about some other things that are actually pretty important concepts, like an anti-corruption layer, which is a way that you would interface with an existing system without polluting your own domain model. And then how to build this out yourself. You can do this really easily. You can just fork this repository and spin it up on GitHub Codespaces, and you can work right through a hands-on tutorial around this. And you can work on that at your own pace if you would like. We also do these locally, so if you're running OpenShift, we can come spin up this kind of thing on an OpenShift cluster for you too as well. We do quite a bit.